Hello and welcome to the bonus section on RIP. We're going to have a little look at RIP and see exactly how it works, and we're going to do this on both Juniper and Cisco devices. So let's get cracking on to the next slide. As we can see, RIP stands for the Routing Information Protocol. RIP is a dynamic routing protocol that uses hop count as its routing metric. It's also known as a distance vector routing protocol. It has an administrative distance of 120 on Cisco devices and an administrative distance of 100 on Junipers. RIP also works on the network layer of the OSI model, and RIP also uses UDP port 520. We will see some wireshark captures to show this. Link speed or delay is not considered in RIP. The Routing Information Protocol uses hop count. The hop count is the number of routers between the source and the destination network. The path with the lowest hop count is considered the best route. RIP prevents routing loops by limiting the number of hops available in any given path, and the maximum amount of hops that are allowed for RIP is 15. If there's a count of 16 or more, then the route is poisoned and is unreachable. So the features of RIP: it updates on the network every 30 seconds, and updates are always multicast in RIP version 2 and RIP NG. The dead timer is 180 seconds, and after that, if no routes are seen, there's no updates, then they're flushed in 240 seconds. Every update has the complete routing tables included in them. So if you have routers that have lots of routes, then these 30-second updates can get extremely big. So routers always trust the routing information it receives from another neighbor. This is known as routing on rumors. Basically what this means is, unlike ISIS or OSPF, where they have an awareness of what the other routers know, because they're being linked state, they know all the routes that all the other routers know. RIP doesn't do this. RIP only knows what's sent to it, and it accepts what's been sent to it on face value. So let's have a quick look at the RIP versions. So RIP version 1, which no one really uses anymore, it does send all its updates as broadcasts. Now, as we know, broadcasts are sent to the all Fs addresses or the 255, 255, 255 address. RIP version 1 also supports no authentication, and it is classful only, so you can't do any classless prefixes in it. These limitations have been overcome in RIP version 2. All updates are sent out as multicast, and the multicast address is 224.0.0.9. Update messages support authentication, and it supports both classful and classless prefixes. And then the last one is RIP NG. Now RIP NG only supports IPv6, and like RIP version 2, updates are sent out as multicast, and it uses the multicast address FF02::9, and it only supports classless prefixes. So here's a list of the commands that we'll be going through in the next video that we do, where we're setting up RIP on both Junipers and Cisco's. As you can see, the Juniper commands are vastly more than the Cisco. So if we start with the Cisco commands first, it's relatively straightforward. With Cisco, all you're doing is typing in router RIP, in the config terminal, and then you're putting in whatever network that you want to advertise. So this is just an example network, and this will be in a loopback. You'd put in version 2 as well for the Cisco, and you'd also type in no auto summary. The reason you'll do this is so it doesn't summarize these networks. So for argument's sake, if you didn't do this, this network here, the 3333, would then be advertised out as 3.0.0.0/8, and that's obviously not something you want, especially bearing in mind this is a /32 loopback address. Consequently, for Juniper does things somewhat differently. You have to go into the set protocols RIP, and then you need to name a group. Now, I've used the term RIP here for my group name, and then everything else to do with RIP is done under the group. So then our next option would be set protocol RIP and our group, and then say what neighbor it's going to be. So unlike Cisco, where we've advertised out a network, we just advertise a neighbor, i.e. the exit interface that is going to go on, and it will take whatever IP addresses or networks are on there. So once you've done that, we need to then set up an export policy. Otherwise, what happens is that no routes will be exported into the RIP protocol itself. So we would do the set policy options and then a policy statement and give it a name. I've called it RIP routes. And then your first term will be from protocol, whether that's direct or whether it's static. I've chosen direct for here. And then I've also done set policy options, policy statement. Again, I've called it the same RIP routes, term 1, and from protocol RIP. And then I've set the policy options for the defense statement of accept. The last option you need to do then is go into the set protocols RIP group, because as I said a little while ago, everything's done under the group. The group in this instance is called RIP, and you do the export RIP routes, and that will put everything into the actual routing table. Okay, let's have a look at the next slide and see what we have there for you. Okay, so we have a wireshark capture here now, and let's have a look at this wireshark capture and see what we can see. All right, so we see our Ethernet frame, so our layer 2, we're sending from the source of one of the routers to the IPv4 MAC address, and this is the IPv4 MAC address here for the multicast IPv4 9, so it's 01.0.0.5e.0.0.0.0.9. Okay, so if we have a little look at layer 3 now, we're dealing with the IP addresses. We're seeing it's being sent from my router's IP, and then it's going to the multicast address of 224.0.0.9. And you'll notice here as well that the TTL is only 2. Unlike most packets where you can get like 64 for Juniper or 225 for a Cisco, the TTL is only at 2 here because it's only supposed to be going to the next hop. Now we can see here that layer 4, this is actually a UDP, so user datagram protocol, and the port is 520. Last thing, we can see that the update message contains the routes. In this case, this is sending the loopback address of the router in this update message. However, if this was a production router that had tons and tons of routes, then these routing updates could get extremely big. Okay, so in the next video, we're going to actually have a look at how RIP is actually configured and working. Thank you for your time, and I hope you've enjoyed this.